1, 2, 3.
1, 2, 3 works.
This is yours, yeah?
Yeah.
Okay, hello everyone, and welcome to Beekeeper. So I would like to ask everyone to slowly take your place. If you want to grab a last beer or a Coke Zero, go for it. It's in the fridge there and they're behind you. And when you finish drinking your beer, please drop off the glass or the aluminum to Mr. Green, which are in the both places. That's just ask from my side. Okay, so we'll be starting. First of all, welcome everyone for the second Zürich AI Meetup organized here by Beekeeper. I'd like to thank so much Beekeeper for hosting us and giving the place, as well as sponsoring the food and drinks, which is amazing. Thank you for that. And without postponing anymore, I just wanted to add you that after each questions, we are also connecting to the Zurich office in Krakow. So there will be a round of questions from Zurich and then from Krakow, just for you to know. My name is Michał Koźmiński. I will be your host today. I'm a principal software engineer at Beekeeper. And if you're interested in talking on our next meetup, just reach out to us, contact@zurichai.club, or directly on the meetup as you wish. And I'll give you a second to take a photo. Yeah, why not? Awesome, I see everyone is done. So I will leave this scene for Valery, who will talk to you a little bit about RAG. So Valery, scene is yours, and I'm turning off my screen share.
Thank you very much. Hi, everybody. Great to be here today, talk about AI. Also great to see that many people actually are interested in AI. It's always rewarding to talk about stuff that is interesting to the people. I tried to balance and keep today's talk not too technical. On the other side, in some moments, we'll probably dive a bit more into how we do things. If I manage actually to make it full screen. Yes. But yeah, first things first, my name is Valery. I'm software engineer with quite of background on the back end. I was doing architecture. Yeah, also worked for different companies. And yeah, moved to Switzerland a while ago and have some hobbies, family. And basically what we do in our company, which is called Coresystems, we built a product which is called Insight Loop, and we give our products to the customers that do service. In particular, we are interested in the companies that do field service. And field service is all about reparation, maintenance of equipment. So generally, the workflow you see here on the slide, and we focus today mainly on the last two pieces of this workflow, where we provide the product that can be used as a knowledge base for technicians, for support engineers to resolve issues with equipment fast. And just to give you a feeling actually how it looks like, just quickly log in. The product has evolved actually quite a lot over the last years. We started almost 3 years ago. And it will take some time actually to go through all the features, which does not make sense. So I'll focus on the knowledge base search, RAG, how we do it, because later in the slides you will see what is under the hood there. This is inside loop knowledge base. You see on the left side as many GPT-like products or chat systems. There is a conversation history, couple of modules that can be used. And essentially, if I'm a technician who has a problem with an equipment and I want to fix it fast, I can use inside loop by asking this question. Or maybe just clicking here, it's one of the most recent questions. What should I do if the generator fails? And then what we do, we look at the past service cases. We have that from the CRM system or ERP system of the customer. We do the pre-processing, clustering, whatsoever. We figure out, based on the symptom that is given, generator fails, what could be the root causes of it. And then based on the statistics analysis, we figure out, all right, we see that most probably it's electrical fault due to overheating and whatever. We give the probability, rough probability of it, and then we also say there are some spare parts that you might need actually to fix it. The second part of it is we go to the knowledge base and we do the document search. We have all the docs from the customers, and then we will also say, all right, if you have this symptom, generator fails, what you should do, you should actually look at the converter mechanism and then follow the procedure. Then there is also guided troubleshooting. If I'm not happy actually, or this thing didn't resolve my problem, I can start the guided troubleshooting and then select different symptoms, and then like these co-occurrent symptoms would trigger the decision tree for which I can go, answer the questions, and essentially, yes, no, yes, no. It tells me it might be the problem with this converter failure caused by cooling system issues, for example. Right, and then also the instructions how to fix it. We build all that to make the customer more efficient, or the technicians basically more efficient. And now I will go back actually to my slides here. And we build it on AWS using this technical stack, quite some services. Essentially, it's on the backend Python with LangChain and other AI-related libraries. Then on the front end, we use React. And for persistence, it's mainly Postgres. And then, of course, we have vector store, which we use for semantic search, but I'll come to it. The architecture now looks like this. It's high level. We like microservices. Actually, I'm a big fan of domain-driven design, so we build it. We try to follow it as much as we could. It's event-driven, and essentially what happens, we connect to whatever data source the customer has, whatever has an API, let's say. We push the data from the customer data source. We do some ETL, and then we publish everything to data streams, and then microservices are consuming this data, and then they're good. You see, we have multiple applications, so one of those you already saw. And today, I will be focusing mainly on this path, where we use the immersive assistant, the assistant that you just seen, to do the lookup and the knowledge base after we identify the intent. But yeah, maybe I cover that a bit later. Step back, before we actually came to the architecture that you just seen, we started really simple. It was around 3 years ago, and we thought we should actually build a system that can predict the root causes based on the symptoms. What can be easier? It was not actually easy. At the end, at that moment, there was no ChatGPT, nothing like that. At least, yeah, not true. It was available, but it was not really hypey. And it was not really something that one could easily adopt at that point. And we thought, all right, we do it classical ML style. We took the BERT topic and we try to pre-train our model using SageMaker. It's a service on AWS, MLOps. You can basically build, you can have multiple jobs, training jobs. You can fine-tune your model, evaluate the results, push it to production through registry and so on. Very powerful tool. The tool is great, but thing did not work. And it did not actually work because, unfortunately, we didn't have the data, the right, or let's say the data of good quality, and the data that was enough to fine-tune the models that we tried. We tried also Llama 2, like fine-tuning the last layer, but also didn't succeed there at the end. And then it was the time when we got to know that ChatGPT could be used for something that is called RAG, Retrieval Augmented Generation. And then we said, all right, what if we try to solve the same problem with a different angle, from a different angle? And looked at it, essentially, we said, okay, let's give it a try with the data that we currently have, same data that we use for training of our custom models, of foundational models. And we use the embedding model, basically ADA, to generate the vectors, basically, which then were stored in the vector store. A classical approach, nothing really fancy here. Just so that I understand how many people actually know and understand how the vector semantic search works. Okay, quite some. Then quickly, basically, when we talk about semantic search, it's not about exact match. It's about taking some text input, converting it to the vectors, like you see here, and then storing these vectors. It's an array of numbers, essentially, in a special storage, which could be used to find not exact match, but the match with semantically close results, let's say. You can see here, there is a white cat, black cat, and so on. So those entities that are semantically close would have the same or not same close vectors in this n-dimensional space. And the entire idea is that vector store could tell you or could help you to find the relevant information, even if there is no exact match with the input string. So we went and we say, all right, we pushed everything to the vector store, all the documents, all the data that we had. Now we ask user to put in the question. The question was, again, no image on the screen. Then we're using the same embedding model. We go retrieve something from the vector store. And then these documents that we are found in the vector store, together with the question, we gave to LLM, and we asked LLM to answer the user questions using the sources we just found. And it worked 80% of the cases, I would say. But on the other side, we also noticed that there are challenges. First of all, it's not always about semantic search. So sometimes you actually also want to find the exact keyword search. In our domain, it's often about finding the exact error, having the error code. You type in just the combination of characters. They do not have any semantic meaning, obviously. Embedding performance was not consistent across languages. And we saw that, for example, if I have a lot of German documentation, I upload it, I ask a question in English and in German, and the difference was obvious. So we saw that with when you ask in the same language, you actually get way better retrieval results. We also saw that we can't really address all the needs with a single prompt. Whatever user asks, and there might be multiple intents. I'll come to this intent detection in a sec. It was difficult actually to cover everything with the same prompt. We also said that we want to remain or retain the conversation history So that, like the experience everybody has now in ChatGPT, right? You ask the question and you ask it in the context. It doesn't come out of the blue. It's somewhere, the context is retained, and the LLM actually knows what was the previous conversation about. And we also saw that many documents, they contain images, diagrams, schemas that actually can help to resolve the issue or answer the questions, but we were not using it. And we decided to build something a bit more advanced. We said, okay, first of all, we need to figure out what the user wants. Because it actually, based on the intent, we can then perform the set of actions to retrieve the necessary information from different sources, maybe process it on the flight. It also depends on the intent, and use a specific, tailored for this intent prompt later on. We also said that sometimes when you type in something in the input field, not everything actually is relevant. So we pre-process the input from the user, and we strip out the things that are not actually useful, fix typos, and so on and so forth. We add the conversation history. We translate all that to all the languages that are supported in the customer knowledge base. Then we embed it in parallel, both languages, or as many languages as we deal with. We produce embeddings, and we also give the text representation of the query to the hybrid search store, which can do both. It can do the vector store, the vector search, and keyword search, like BM25. And then we combine all that. We combine the results of both searches with re-ranker, like a re-ranker, really to identify what are the best matches from all these results. And we load on the fly the images, which we extracted before, so that all that, like best matches, together with the images we give now to LLM, thanks to the latest models which can do that. And it gave now over 95% hit rate. So if the information is in the knowledge base, then we pretty much are able to find it, regardless how you ask it. Well, of course, it still has to make sense. But if there is a somehow semantic similarity, or it's close, it's almost certain that we find it. And that was all done for a single intent, which is troubleshooting. Troubleshooting because there is a problem. I have no image on the screen. Obviously, the user wants to troubleshoot the situation and get the resolution steps, how to fix that. All these yellow boxes are specific to that single intent, and we have actually quite few those intents. So you can imagine that this chain, it doesn't remain like that for every intent. It actually changes, depends on what is the logic behind each intent implementation. It's actually also, I wanted to say a few words about vector database, because I think if we would do it again, I would probably dedicate a bit more time to do proper research, as it was time consuming in our case. We started with Chroma, because it was easy to start with, has some embedded mode, so you can really just start within 5 minutes. But when it came actually to productize the setup, was not obviously the great choice. We also didn't have, at that point at least, I'm not sure about now, there was no SaaS offering, so you need to run it yourself, and that we didn't want to do. So we switched to Quadrant, and later we figured out that there is no hybrid search. When we switched, we didn't actually pay attention to it. We thought, all right, it does vector search. It has a SaaS offering. What else do we need? No, actually, to squeeze maximum out of it, BM25 also brings quite some good positive results. And eventually we migrated another time to VV8, which we are now happy with, I would say. The only weird thing is that with VV8, it scales, but you need to tell them in advance that you want to upload a lot of data, and then they will scale it for you. It's a bit weird. It runs on the cloud, but there is no native auto-scaling that you would expect from database provider. And actually, we got to know also Postgres can do a good job. There is no BM25, but there are some other alternatives. We said we don't migrate now, but maybe in future. And we are now thinking also about agentic frameworks that popped up like a year ago, maybe a bit more. And these days we're actually working on changing a little bit the approach, putting the agent in the center of the entire conversation with the user, in the sense that if the user asks the question, engine does not start, then engine does not start, then the agent could actually go and see the service history and figure out that recently this technician worked on ABC 1000 engine, and ask back, is it that one? Yes, of course it's that. And then looking into the symptom catalog, it could ask and correlate that the engine does not start often comes with engine does not make any noise, like it's dead completely. And using the symptom catalog, then generating this follow-up question, which could be answered, there is no sound indeed. It could go to another service and figure out that the battery is due to change, and then ask to measure the current voltage. And after the measurement is there, the diagnosis can be produced like, yeah, but the battery is dead. It requires, so we are doing now research in multiple areas. We are checking LangGraph. The LangChain has, of course, like their agents, right? And yeah, we were thinking of checking that a bit more close and maybe start with that. Then LangGraph is something that could be used on top to, yeah, also for more complex scenarios and multi-agent implementations. And also on Bedrock, since we're on AWS, there is also offering of agents. This is something also under consideration at the moment. And last thing I actually wanted to mention, we didn't really give up our own models or pre-training our own models, because we realized that the LLM as, let's say, we could consume it as a service through the API. And it's good for quite some use cases, right? It works. Why to train own model if you can consume something that is already available? On the other side, there are cases where you still want to do it yourself. And we have a couple of models that we train on our own for time series forecast predictions and a few other cases, as you see here. So basically, both things could work together in a single product. As usual, it's about choosing the right tool for the right task. Nothing new here. It's just proves again that it's indeed the case. Thank you.
Thank you so much. So we'll take questions firstly from Zurich. Anyone has any questions?
Hi. I'm curious, you got the same performance, similar results with the on-prem versus the SaaS?
Sorry, could you repeat?
The models, you ran them locally and you ran them in the cloud, and you got similar results? Is that what I understood from the last slide?
No. The point was these are the different use cases. And we use like LLMs available as a platform as a service for some of the use cases. and it works great. On the other side, there are use cases where such LLMs would not do a good job. And therefore, we go for our own fine-tuned models.
Okay. Yeah. So pomegranate's your own.
Yeah.
All right. Thanks.
Hello. Okay, I'm here.
Yes.
The RAG framework that you presented, I'm curious to know how it's different from off-the-shelf products, features in ChatGPT or Google Gemini. So now you can, all of these big tech companies have integrated RAG into their products, and you can upload multiple 1,000-page PDFs. I don't know what's happening with regards to vector databases behind the scenes, but maybe you can just make a comment on how what you've built, what RAG you've built is different from what all of us are familiar with.
Yeah, it's a very good question, actually. And to some extent, you're right. So basically, you can indeed upload a PDF of 1,000 pages, and it will answer the question. When we talk about the volumes, and we really have the cases when we have documents, which like overall size is several terabytes, overall number of pages is about 2 million or something. It's not an option, to be honest, to upload all that. It's clear. Customers also don't want to do that. So they would prefer that the data stays with us on AWS, especially those customers that already run stuff on AWS. That's even easier, make things easier. Then it's a data protection question that we help to resolve. And with all the customization and specific needs that are specific for service and field service in particular, I didn't cover it here, but you can imagine that there are some specifics of the domain. In the prompt, we also do a lot of, we provide some domain-specific, how to say that, things, which you would not have with just opening ChatGPT, uploading the file. So here we see our advantage. Of course, it's not only about documentation, but also past service cases, which we also work with. One can say you could also upload the entire service history from a CRM system to ChatGPT, but it's also not happening for, not easy. Sure, thank you.
Any other questions?
How large are some of the LLMs that you're using, or how small?
How many, sorry?
How small are some of the LLMs that you're using?
Yes, so we use Haiku. Haiku 3.5. We use Sonnet 3.5. So we use Anthropic LLMs. We started actually with ChatGPT originally, but now migrated to Anthropic models. And we also tried, that's our experience. We also tried the latency optimized Haiku 3.5, which is available only in US, especially for the tasks which require super fast response time. But for some reason, for us, it was slower than using the normal model 3.5 in Europe. Here, I would not just say, something didn't work on AWS side. It would be that it didn't work something with our setup. But since it was a matter of 200 milliseconds, we said, for now, we don't invest too much into this topic.
Is there any intention in training your own models and then using them, hosting them yourselves and stuff like that, or not at all?
Not at all. At the moment, we were thinking about DeepSeek. It's probably many companies could, at least I heard, were thinking once it was out. But in our case, we said it would not probably bring a lot of value anyway, because the models that we use them from Bedrock, which is the service on AWS. The data is anyway in AWS already. So we don't share the data which is already on AWS with another provider. And we could just benefit from what is already available. Customers do not, they don't really, they are not against this setup. And furthermore, no data is used in Bedrock, no customer data is used in any way, which is another benefit. Hugh?
Hello. I have two questions for you. The first one is about your chunking strategy. How do you chunk your document? And the second one is about the embedding model you are using, if it is a standard model or if it's something that you fine-tuned. Thank you.
Yeah, thank you. Yeah, good questions. So the chunking strategy, we actually were experimenting quite a lot with it. Starting from using the layout of the document. No, we're actually starting with different size of chunks without considering the layout of the document. Then we thought, all right, let's try to consider the layout of the document and chunk based on the paragraphs, for example, with minimum size and so on and so forth, which is currently the strategy at the end that we stick to. Surprisingly enough, with the documents that we had, we didn't see a huge difference if we were chunking by paragraph or by some limited window size. In any case, in both cases, we still do an overlap between chunks, right? And we also, after initial retrieval from the vector store, we augment the retrieved chunks with neighbors. There is also like a strategy to add 5 more after and maybe 1 before, for example. So this is how we did it. And regarding embeddings, we just use other 3 now, large, 512 dimensions, if I recall correctly. No fine-tuned, just as is.
Question? If not, then we'll move to Krakow if we have any questions from Krakow. That's going to be a little bit experience, just hearing the question. Let's see.
Yes, hello, this is Krakow. We have at least one question, so over to you.
Hi, can you hear me?
Yes.
Okay, guten Abend, Zürich. In our team, we are facing also a ChromaDB issue. It looks like it's not really built for robust production. And one of the vector DBs that we were planning to evaluate is also Weaviate. So do I understand correctly that with Weaviate, you are forced to host all your data in the cloud? You can't do it on-prem?
Yeah, thank you for the question. No, you can run it yourself as well. There are also some templates that, again, talking about AWS CloudFormation templates, which actually help you to do it if you want to run it yourself. So it's an option. For us, we wanted to find something that just does not require any maintenance or any operational efforts to keep it up. But essentially, you could do it on your own. I think it even runs in Kubernetes or ECS, if I recall correctly. Of course, with some persistent volumes, that could be done.
Okay, thank you.
Hello, do you hear me?
Yes.
Perfect. I have a short question. You just said that you want to build the agents using LangChain in the next round. But my question is, LangChain, as I know in my knowledge, one of the most known libraries, in the world for AI, because they cover some areas. They combine with the Llama, and now they want to do their own. Not now, they're even doing their own multi agents. Before, personally, I was using Microsoft AutoGens, and after they created Llama, LangChain created these agents of themselves. I now testing them too. It's also looking well. So my question: why the LangChain wasn't the first idea for you to use? Because it's really useful and really well known in the world, and they have so many connections. Not as a company, and I mean the endpoint for API, etc., with different companies. So it's really useful. They also support embedding or any chunk or logic, etc. You could cover everything using on the LangChain, or also transformers as a second option. Of course, both of them use everything and also open source. So that's why I want to ask you, why didn't you choose them in the beginning, but put as a last option for the moment?
Yeah, thank you for the question. In fact, LangChain is one of the preferred, if I understand the question correctly, is one of the preferred options for us because we already use it anyway. The chain, the pipeline that you saw, which we implemented for one of the intents, it is fully based on the LangChain framework. And therefore, we kind of, we already are familiar with the framework. And it's one of the most popular ones with the pretty big community. Therefore, we thought that would be the natural choice. We didn't make the decision yet, as I said, so we are looking into alternatives now. It could be that we would pick something else, but for us, LangChain would be, at least like as of today, it's a preferred option.
Thank you. Can I ask some more questions shortly?
Sure.
Do you guys planning to make it multi-agent? Because I know a lot of companies, including my own, that's building multi-agents for tons of different areas. But currently, I only seen a RAG agent for your knowledge bases. So my curiosity, like what areas you guys also want to build with different agents for what unique value you would have for your company at least?
Yeah, we might see two agents that might play together at this point. One is about RAG and knowledge-based search. Another one is about, we call it AI-guided troubleshooting, which is more like, it's not really about knowledge-based search. It's more about starting with a very generic question, like engine is not working. And then there might be 1,000 reasons actually why it's not working. And of course, you need somehow to guide the user, not necessarily using the knowledge base, which will be one of the tools that we see, but also other sources, including like past service data and so on and so forth, different catalogs and so on. And we see like at least two domains where we could create two separate agents. I might imagine there might be three or four, but it's a bit too early to say, if it's going to be the case or not.
Thank you. That's, I think, good for you also. I'm happy to hear it. Everyone does agents. Also me too, Beautiful. Thank you.
Thank you.
Awesome. Thank you. I think we have maybe time for one more question from Krakow, if there is any, and we'll be wrapping up.
I think we are good. Thank you, Michał.
Awesome. Thank you. So thank you, Valery. And yeah, thank you so much.
Thank you.
Also, if you then want to talk later to Valery, I know that he's staying for the later networking time, so you can ask questions in person an hour. Okay. That's good. Yep. Awesome. Seems like it's working. So now it's my turn. I'm going to talk to you a little bit about ClickHouse as a foundation for scalable and drift-resistant AI predictions. My name is Michał Koźmiński. I'm a principal software engineer here at Beekeeper. And if you want to follow me on LinkedIn or Medium, I'll also give you a link at the end. I'll also on Blue Sky. A little bit about Beekeeper before we start. So what is Beekeeper? Beekeeper was founded in 2012, and it was designed to help frontline workers. So despite that frontline workers represent 80% of the workforce, they are very much underrepresented when it comes to technical aspects. So Beekeeper tries to give them option to actually use technical support as well as having the success empowerment system for deskless employees. A little bit about numbers. We have over 500,000 weekly active users, 5 million open chats monthly, 150,000 posts written, and adoption is around 85%. What I mean by adoption is that whenever we deploy it to our customers, it's over 85% usually, and we run 4 data centers: US, Europe, Switzerland, and Germany. So let's talk about ClickHouse and how did we get there? So our data scale, we have around 500 write operations per second when we talk about our data warehouse. The merge tree, which we're going to talk about later, is 1.6 thousand per second, 6 terabytes of data when I checked on the 1 data centers, and we have 4 of them. Just to give you an idea what kind of data scale we're talking. So it is a little bit of data, but if you work for the insurance company, banking, probably you have way more, and that might not apply to you. Just to give you an idea, whenever you think about using what I'm talking about right now, will it apply to you or will it not apply to you? So we started with having Redshift. On the beginning, we had a Redshift, and we really much struggle with how fast it grows and how slow it becomes. And we look at the ClickHouse, and actually moving from Redshift to ClickHouse give us 10 times compression. So when you think about the 6 terabytes, that would be 10 times more on a Redshift. Also, when it comes to the performance, we saw that processing 80 million rows for our daily active users, which in the last 3 months, takes 3.5 seconds. Took around 20 when we had a Redshift. So we see huge improvement when it comes to performance. But the other thing which we want to do is we want to have a central place for all of our prediction models. How do we predict future? How do we build our machine learning AI features into the product? So we started to look into some of the classic data pipelines. And what we really did not like about the data warehouse was the transformation stage, because usually it would be done by the external services. So you would have a Redshift or maybe other type of database, but then you would transform the data and you would save it in another place. And that was something where we felt like, I would like to merge it together. We don't have such a big infrastructure. We don't have so many requests to separate it and have a separate streaming, processing, maybe ACCA or something else. It didn't really make sense for us. We wanted to have something simple. And we started to look on the ClickHouse, and we actually run a ClickHouse meetup. So that's going to be a little bit of the cross post. If you're interested on the ClickHouse meetup and you want to learn a little bit about ClickHouse, Beekeeper is also hosting that on 24th, I believe, of March. And there's a guy behind, Andrei. He is a ClickHouse expert here. So if you want to talk about ClickHouse to him, please talk to him about that if you're interested in that. Also in the meetup, Andrei is also running the meetup here. So let's look on our data structure. So when you look on our data structure, and for people who are in Krakow, I'm sorry for the small letters, but I'll try to explain everything step by step. The important thing for us, we had a data source. So it's a data lake. That's S3 files, that's everything you have, maybe stored somewhere in a different places. And then you have a streaming services, maybe Kafka, maybe Flink, whatever you have there for streaming data. And we pushed everything to our feature source, which is ClickHouse. But then nice thing about ClickHouse, it has the transformations built in, something which we didn't see in other databases. So we could actually start with a table which was called user activity _ raw, and from it actually build up how many active users you have per day, what kind of operations they perform, and so on, just from the one table, and then exponentially create a different tables which would be transformation on it on a single platform using the SQL. So for us, that was great. Like just one thing to manage and not a couple of things, and everything is in one place, easier to work with. So whenever we have that, then what we do, we have a training platform and a pipeline. I'm going to talk a little bit about this later, but we explored with multiple things. We ended up with the SageMaker on AWS. And later, whenever we have a model, we'll also pull from our ClickHouse and use it for the inference pipeline to predict actual values of our model, and then we host it to our application. That's it. A little bit about ClickHouse and what makes it different from Redshift, Postgres, or other thing. As you probably know, Postgres is a row-based database where every single row is separately stored. So whenever you pull only certain columns, you anyway have to pull all of the rows, where ClickHouse is a column-based. So probably you won't be running your application on it, but for predictions, where you may be interested only in one column, which is like timestamp, or maybe, action or something else, you can have like multiple features. Like I said, we have a raw table with like 70, 80 features. You don't really care if your row is growing in columns. It's completely fine because you have a column base. So every column is stored separately. And then we come to the actually a juicy part of the ClickHouse, which is materialized view and how it works. So that's exactly what I showed you, the transformation layer. We start with the raw table, and then we have a SQL query. And this query might do, where, or maybe that's some transformation, maybe might change to the timestamp and something else. And what we'll do, it will create for us a materialized view. This view will be separately stored on a disk, as you see. So then fetching a data from the materialized view will be super fast. So I can do already certain predictions, certain features sets in a ClickHouse itself, and don't even call Python. Before that, I would have to have a pipeline which would be streaming the data, push it to the Python. Python would like change the data. It's like, oh, on 5th of March, there was 70,000 active users for this tenant, because we will basically count all of the logins. Right now, for me, it's a one SQL query, which I can easily version in a Git. I can have this shared between different departments. I can have a data team looking at it. I can have any other team which want to give it a look and see what kind of features do we have, as well as look into the raw data. I say like, hey, actually from this raw data, I'm interested in something else. I'll create a new materialized view, and they can actually run from it. So this is how it works. So we have a source table, and whenever we insert the rows, what happens is like you have to think about it a little bit like in Postgres, you have a callbacks on insert to do something. This is exactly what the ClickHouse is going to do in the backend. It's going to like, hey, this materialized view is looking at the user actions.raw. Whenever you add something there, please make sure to update it so this selects states up to date. This is not real time, so it might be that you will have a slight delay. So we have it here, eventual consistency. But when you do analytics, do you really care about like 20 microseconds? You probably don't, unless you're doing fraud detection or something else, but we don't. So how does it look like? Imagine, as I told you, like we have here a date time, 1550, 1540, 1530, and we have users and how many updates they perform on this time. Normally, it will be just raw events, user ID update, user ID timestamp. And then we can just put it into the nice materialized view, group by time, make some average, make some counting, make any SQL processing we want in a Word, and have a quick access to it, have a real-time access to the data without having problem of pre-processing. So I don't have to now care if my Python script for processing is alive. Until the ClickHouse tells me it is alive, it is working, I know that my pipelines for processing are still also working and happening. So how do we use materials for the machine learning feature extractions? As I said, materialized views are for processing pipelines. So whenever we process something, we don't use any Python scripts, we don't use any Kafka streams, nothing. It just directly process in a ClickHouse, making it easy, but probably doesn't scale at a certain point. I don't know where yet. We are getting there maybe one day, but I can't tell you now. Now we have 1.6 thousand operations per second, and we are still fine. Andre, we're fine. Like 20% of CPU usage, and we are not even using the very strong CPU. So we are completely fine. Pre-aggregation of the features. So what we can do is we can pre-aggregate features into certain buckets. It's like, here are the features about the user. Here are the features about the post. Here are the features about the chats. Real-time updates for model training. As I said, the materialized views works in a real time. So the moment you do the update, it will also update all of the materialized views, and you can real-time fetch the data in your model if you need. And now the neat part is like, raw tables can be imported from many sources, including S3. So I can directly say to the ClickHouse, your raw table comes from the S3. So I don't have to write any connector. I just say like, here is the S3 document you are interested in. Here please also save it. So I can also say, whenever you finish extracting the feature, maybe for this month's prediction, please save it under this file into S3 bucket, allowing me to actually don't really have that much to orchestrate. So we are dropping the resources needed for orchestration and replacing them with pure SQL. I see it as a win. The next thing is cross-department feature sharing. That's something which we really look into. So we have a data team, but they are not the only team which is using the data. So what we really look into is to make sure that everyone who needs that can connect to the materialized view, give them a look, and they are well described. And you can see the SQL queries which actually build them. So if you want to look like, hey, I'm not really sure if that's exactly what I'm looking for, you can always look on your SQL query, see how the materialized view is built, and bam, you know what's happening. Now imagine the same thing when you have a stream, you have somewhere a Python script, and you have to find this Python script. Where is it? It's harder. I'm not saying it's worse or better, but normally at this scale of the company, of the scale of the building up, you will introduce a lot of bureaucracy where you keep things, everything is in one Git repository, if it has access to it, version, correct naming, it might be a problem. And then identifying something goes wrong. Next thing, single source of truth and analytics for ML features. So for us, ClickHouse is the only place we keep this data. It's like a holy grail. We keep it there. And if you want to fetch something, you don't go to other place. You don't go directly to our analytics services. You go to the ClickHouse. Increased consistency. That's simple, and reduction in duplicated efforts for data processing. You go to the ClickHouse with a nice overview. It's there. You don't think like, did maybe someone wrote something similar? Did someone else use it? You don't have to even think about it because it is there. So if you want to try it on your own, you think like, oh, do I have to install ClickHouse? No, you don't. There is a ClickHouse local, which you can try to install that example how it works. So basically what you can do is you can try, I actually quite often use it to see how pre-processing of, for example, CSVs will look like. You can just load the CSV, and this is the CSV which I actually pulled from the Hugging Face. It's 670 megabytes of comments from Reddit. And it took what? 0.12 seconds to actually process all of them and get a select. So if you want to try it out, the other option is CHDB, which is a Python version of this script. So quite often in the Jupyter notebook, whenever I'll be trying something else and I don't want to do like a real commit to the repository, I'll just try it locally. That's wrong slide. So now we have everything in our ClickHouse. How do we use it actually with the prediction? Let's give a quick look before we actually go through it. We can come back. So how it works for us. This is a logo for ClickHouse. It's a new thingy, so people might not know it. So ClickHouse actually sends data to our Python, and the Python is run by a Jenkins. So Jenkins script, which is like, hey, now I actually need to do predictions. So I'm going to run the Python script. Python script is going to download everything what I need from the already materialized views. So it has super fast access, like 0.1 second to perform it. And then it will create one pandas CSV, send it to the S3 for this month's prediction. And after that, Jenkins will kick off our prediction model. So what we do, we are leveraging the ClickHouse driver, the Python library. That's a basic connector you use for connecting to ClickHouse. Then we save everything into a single like pandas for the easier understanding. So if you then want to run it locally, you can just import the same CSV, run locally some experiments, see if it works. And then exporting data sets for the machine learning training, mostly CSV, and direct export to the S3 is also possible. But for machine learning preparation of the data, I would highly recommend going for the Python because it's going to be like 5 lines of code. Please do the select. But what it gives you is the option then to look at the file, maybe run it locally and see what's happening. It will be a little bit easier to debug, to do it last step, just the fetch through the Python itself. Now, the next thing, we need to actually do predictions. So what do we use for predictions? What do we use for prediction? We started with AutoGluon. Who here heard about this project? No one. Okay. So, so what is AutoGluon? AutoGluon is already prepared framework for training on the tabular data. So whenever you want to predict, I don't know, churn prediction, or maybe if the user is doing something wrong or anything which has a labels, it will try to help you with all of the feature training, with all of the feature extractions, then actually pre-processing the features and running the model which it thinks is the best. So to run multiple models like a random tree and other ones and compare like, hey, this one has to be best results. So the only thing you say is like, please, I only care about accuracy or maybe F1 score. Try to figure out the best thing you can do. So this is basically what we had. Whenever we had a trigger, that's our processing unit. It went to the Python with the S3 bucket which we previously saved. So you can see here we save it to the bucket, and then we fetch the data. We run the AutoGluon, and then we save the predictions. We save it back to the ClickHouse. ClickHouse, as you see, directly pulls it from the S3. But we had a certain problem. It's super nice to do predictions, but you have to think about something called hyperparameter optimization. Anyone knows what is hyperparameter optimization? A little bit of people, that's great. So long story short, what you try to do is you have your models, which you are trying to run on your data, but the model has a certain parameters you can customize. I don't know, number of, like here, layers of neurons, learning rate, and so on. And these parameters actually can have a huge impact on your predictions. So normally you want to try and run a model with like 100, maybe 200 different hyperparameters and see which one is the best. And AutoGluon actually supports it. So as you see here, you can say like the learning rate, please create me uniform from 00005 to 0005. Then optimization type, choose between Adam, W, and SDG, then different choice. So we have options for it. But the problem we started to see is whenever we run it and we updated parameters, we had a result. It was like a cycle happening. Now imagine we want to run it like 300 different optimization. It doesn't scale well. You start to run into issues of worker running for 3 hours before you get a result. And it's a typical problem of like, oh, it's compiling. So now I have nothing to do. Like I have to go and see what's happening later, come back. And maybe you come back and there's a crash in the middle and oops, you have to start again. So we started to feel like, can we actually do it different? Can we start like 70, 80 different workers, which will be, you know, doing what we need? And there's another problem, like how do we orchestrate it? If we run in our Kubernetes, we have to orchestrate somehow Kubernetes. If we run on Jenkins, we will need the workers on a Jenkins. But the good thing is, actually SageMaker has option to do it. So whenever you run predictions the same way as you run on a AutoGluon, you can use the SageMaker version, which is like, hey, please look at these parameters. This is the minimum, maximum, and how it works. And what it will do, it will exactly do the same what I showed you. It will start multiple models with multiple containers running and predicting your model, giving you that's the best option you can have. So this is how we solved the problem of actually reiterating on a data. And now the last problem we had, data drift. Does anyone know what is a data drift and when it happens? We have a couple of people, but let's just have a reminder. So data drift happens here. Like imagine that, you know, you had a feature one in 2019, and this is how the results, you know, from your feature looked like. So the most seen value was 9.5, and everything around it was a normal distribution. But then, you know, more and more people started to use your application. You get more and more customers. So everything shifted to the right side. We start to see, you know, distribution moving to the right side. And now imagine that your model was trained to detect people who are lacking and starting to use less and less of your application. You might start to do a cutoff here, maybe. That's just example here. And this cutoff will not work anymore because actually 8 for the new model is already so low. Maybe they're already gone from your platform and your model is not accurate anymore because that's what happens. The reality around your system changed, so the model started to drift. So how did we actually work with the data drift. So example here is a churn prediction, where we start to train model based on the user behavior, whether churn or not. Their behavior might change over time. They might start using different features. They might use them differently. There might be more people coming, so your model will be not up to date. So model retraining, that's like the best and the only solution I know which kind of works. You just have to retrain your model, and you have to establish, whenever you have a threshold for automatic retraining. One thing we found interesting is actually transforming features. Imagine you have a feature of posts written, like how many posts did the customer write or how many chat messages they write. The more customers you see, the more drift to the right will happen. But if you do the chats written divided by active users on your platform, that might stay more stable. So you can start to look into, hey, I have a data set from a year ago, I have a data set from now. Let me try to experiment with the features if I can find features which are more time stable on this time. And yeah, lesson learned from our journey. Define scope of your data. So define what do you want to achieve with your machine learning AI processing. Are you care for like real time? Do you care for maybe easier deployment? And try to create a process which has the least moving parts. That's something which really bite us. In the beginning, we tried to start with the like classical AI machine learning pipelines. They were just too big for us. They might work for the big companies. It's just depending really on your stage. So that's all from my side. Thank you, everyone. And if you want to read my articles, which I published, you can follow me here. And I'll leave it time for questions if anyone has a question here now in Zurich.
Hi, thank you. Two questions actually. First is, did I get it right that you're currently using ClickHouse both as cold and hot storage?
Yeah. So we currently use ClickHouse.
So both in production and for retrieve historical data. Okay. And the second one is if you're using some frameworks, special frameworks to detect the data drift.
So I must be honest, we try on the beginning using the SageMaker model drift detection, and it worked well. But after some time, we just see that it's not really worth running, because running and experimenting with it takes a certain amount of time, and retraining the model costs us $15 with our data set. So you can imagine I can just retrain it every second month, every third month, and be completely fine knowing that I know my data set. Because as soon as you find your hyperparameters which work for you, retraining the model is not that expensive anymore, because you have to just run one container, for maybe half an hour, especially if you do predictions which are tabular predictions. So that's what we do. We don't really monitor the drift because we just retrain it every second month. We just found that it's too much for us to now do observability of the model at this stage. We might do it, and basically the tool we use is a SageMaker model drift analysis. If you upload the model to the SageMaker model registry, you can do it. What it does, it basically will check for the distribution depending on the data set in the past and the new data set, and we'll see like if the distribution changed too much, and that's it. Will give you information.
ClickHouse is distributed compute and column storage, right?
Yes.
Spark is also distributed compute and column storage.
That is correct.
And I assume there are other frameworks that are both distributed and column storage. So what was specific about your use case that made you want to choose ClickHouse?
I think for us, it was performance and materialized views, which allowed it. So as I said, for us, materialized view was a big update, because we didn't have to firstly upload the data to have like a raw snapshot, and then for the warehouse actually process them and send them again, so have a process outside. Materialized views allowed us to do that, on the place in the ClickHouse, as well as the option for having direct connect to the S3. There are basically a couple of features, and they work with us as well. And the third thing, I really like the having locally option to start a ClickHouse with one binary. Like operating ClickHouse is quite easy. If you want to talk more about like operating ClickHouse, Adi is there behind you. He's waving now. He's operating the ClickHouse, making sure it's running for us. So you can talk to him, and maybe he can show you a little bit of the pain, or I don't know, it's how good it is. So yeah. Awesome. Any other questions? If not, then I will ask if there are any questions from Kraków.
Yes, we have some questions, and this time we'll enable video, so you can actually see that we have quite a few folks here in Krakow. So over to you for the question.
Hi. So you are using ClickHouse as an analytical database. Can you tell very high level how you store your transactional data and how you get it into ClickHouse?
Transactional data, you mean like the business data?
Well, every time a user types something or interacts with your product, I imagine it gets stored somewhere that is not ClickHouse.
So basically you talk about, that's the question. I don't know if you mean basically our domain data, or you mean basically a side effect, which is a log of what user created.
I'm kind of assuming that not all data from your...
Yes, we have SQL database. So we have Postgres and MySQL. That's where we have our domain data, the one which are allowing the application to run. But all of the analytics, so for example, when user clicked and does something, it's streamed to the ClickHouse.
Okay, so ClickHouse is always up to date.
Yes, it's always up to date.
Okay, thank you.
We have one more question from Krakow.
So my question is actually to the AI guy, but he's not here, I guess, anymore. Or maybe your colleague also can respond. This colleague. Just my question was, I couldn't ask. I asked 3 questions. You know, that's why. What forced them to move from OpenAI to Anthropic? And are they happy with the result? Or the result are close to each other? I'm really curious about that because personally, I'm kind of against Gemini, for example, because I like OpenAI a lot as a result, or Azure also, really good one. But Anthropic, I like it, but I never tried yet. I was just curious between them, what forced them, and if they like to have the result at the end.
Yeah, thank you for the question. Yeah, we moved. Basically, one of the reasons was we didn't want to share the data with OpenAI, and Anthropic models are available inside AWS. That was one of the big benefits, and we actually saw that the migration is pretty fast. It took us essentially 2 weeks for the proof of concept and tests, and another 2 weeks to roll it out in production. It was literally 2 sprints to migrate without any regression. Performance was pretty much comparable what we had with OpenAI.
And my second question about this actually then, so you said you didn't want to share your data with OpenAI, but rather with Anthropic. So are you sure 100% that Anthropic is more secure? Do they serve any kind of paperwork to you guys as a company that you can count on them? And beside that, for example, you said that the transfer, immigration from OpenAI to Anthropic was 2 weeks. So I was curious, would you even try or think of it using Azure, for example, which also really useful, that created by the Microsoft, which is more secure compared to OpenAI itself, if you compare the security reasons. So have you ever thought of using Azure instead of transferring everything to the OpenAI to the Anthropic? So I also want to learn about this part too.
Yes, but again, since we are running anyway on AWS, we actually wanted to keep the data inside AWS because it's way easier to convince customers that we share the data with one cloud provider and not with 2. And that was basically one of the reasons. Microsoft, if we were running in Azure, that would be an option for sure.
Okay, I think that's clear. Now I know why you use Anthropic. Okay, perfect. Thank you.
Sure. Thank you for the question.
Welcome.
Awesome. Then Krakow, Tomek, is there anyone else who want to ask a question?
I think that's it for now. So thank you.
Then we will start with a 10 minutes break, and then we have a last talk. And after that, you already survived hour and a half here. If you wait 20 more minutes, we'll have some small snacks coming and a networking. And there'll be going to be a last talk from Luca. So we'll see each other 35 past. If you want to use the bathroom, you go out and left, and there is a bathroom there, beers are in the fridge. Please drop off the beers after you finish to the Mr. Green bag. That's it, and we see each other in 10 minutes. Thank you. For now, okay. Zoom call. Okie dokie. I would like to ask everyone to come back, grab your beer, grab your snack, and we have a last presentation of the day by Luca. So yeah, please get your back to your place. Or not to your place, wherever, just let's prepare for the talk.
Test, seems to work. Background music is always welcome, right? Not sure, but that's okay. I need to join again. I need to rejoin the Zoom meeting. Give me just 1 second. In the talk. Okay, I don't need to join with the computer audio, right? Good. Perfect. Okay, let me share my screen. So the title of my talk is pretty ambitious because it says from Bedrock agents to model context protocol, what, why, how. Let's start. Thanks for coming. My name is Luca Perrozzi. I'm a solutions architect at AWS. Background in physics, then consulting, and then I landed in this small startup and specialized a little bit in AI/ML. I would like to ask, who has experimented with agents? Can you raise your hand? Experiment. Okay. Who has experimented with the model context protocol? Who knows what model MCP or model context protocol is? Okay, this sets the bar. Perfect. So I would like to go very, very fast through just to bring everybody to a minimal set of concepts that help me, especially during the demo. No? So an AI agent is an intelligent system that plans, reasons, and acts. So differently from a language model, is able really to then take decisions. Can access typically enterprise data or data in general, and uses tools. Tools is a very specific concept because imagine you have inputs like a prompt, conversation history, and you have a foundation model. Like you would like to connect, in this case, it's an insurance claim example. No? You would like to ask somebody, the user, to a set of tools in the back. Could be API calls, could be search engines, like this RAG example that was presented in the first talk. And an agent is nothing, quote unquote, nothing but an orchestrator that is able to connect really a request that is typically written in natural language to a set of tools, more or less complex, through a set of steps that are kind of predefined on the basis of what the request is. So there is a lot of back and forth between I ask some question, the language model tries to understand what this question talks about, needs to plan, needs to execute, needs to send back results, and then the language model will elaborate a final answer. This is a typical workflow of an agent. There are many frameworks that can be used to build an agent. On AWS, we have, of course, a platform that is called Amazon Bedrock. I will not annoy you with a lot of details. The benefit, if you want, of a platform like Amazon Bedrock that also Valery talked about is the fact that there is a very large number of language model providers in particular, not just these, but these are the ones that you can have as pay-per-use API. And the flagship models are typically the Anthropic ones, although we also have some proprietary models. So the idea is, if you think about a knowledge base in particular, it is already a form of agent per se, because typically, as Valery already showed, you have a query, you have a language model, but then you have, or you need to hit some of the results that are living in the knowledge base, and you will need to elaborate what comes back. You can think about the knowledge base as a tool, one of the tools that could be under the belt of an agent. So let's dissect a little bit more the agent. And there are, as I said, many, many different frameworks. So let me try to dissect a little bit the Bedrock agents. And in Bedrock, there is what is called action groups. What does it mean? It means that you need to have a description for this tool, action group and tool. Unfortunately, the naming is always very confusing. But let's say that when you have a tool, you need to have a description of what this tool is able to do. Possibly you want to add an API schema, because when you want to reach one of these tools, you need to know how does this tool work, what is expecting as an input and what will return me as an output. And then the way we implement the compute, if you want, runtime of these tools is through Lambda functions. Lambda functions are, you bring your code, you pay per use, it just runs when you call it, you get an endpoint, everybody's happy. So just as an example, when we talk about action group / tools, you can bring your API schema and then you have your code. And if you add your description, this action group provides a set of, this is really natural language because it needs to be interpreted by the agent orchestrator. The agent orchestrator will need to know what this tool is doing in natural language to decide whether this tool is the right tool to satisfy the initial request from the user, or we need to go to another tool or another agent, and so forth and so on. So setting up an agent is extremely tedious because you need to write a lot of code, you need to write a lot of API schemas. It's extremely boring, in my opinion. There are other frameworks that have different opinionated views of building the agents. And in particular, LangGraph, that was also mentioned, is a node-based agent. You have edges, you have conditional edges, so you actually are able to inject already logic when you define the agent instead of just letting the language model decide by itself. So it's a bit more structured, it's cyclical, it can loop. It's a different way of building. So agents typically start very small. You start to build an agent, you have a few tools, and you are happy with what you have. In this case, I don't know, an HR agent that wants to return the time off. Then you get hungry. You build a version 2 and say, I will add more tools. HR knowledge base, because people search for policies. Okay, still works well. Now I get more hungry. I want leave of absent actions because maybe I have somebody that needs to take a sick leave or whatnot. And so the agent starts to grow and to grow and to grow. And then at some point, it will not work anymore. Because the coding, first of all, is getting super complicated. The agent gets confused. How do you differentiate the leave of absent with respect to vacation if the question, for instance, is not written super clearly? Everything is based out of description, so natural language. You need to label a tool on what it does and what it doesn't. And become also slower and more expensive, okay? So these are typical patterns. Guys, I'm coming to the MCP. Allow me to build the momentum, although you are hungry, I know. At this point, you are starting to think, and we are starting to observe, trends in the multi-agent collaboration, right? It's not anymore a single agent that does a lot of stuff, But the way Amazon Bedrock in particular thinks about it is through a supervisor agent that is able to route requests to different sub-agents, and each of the sub-agents might have different tools in its belt. This is not relevant. Now, there are different ways of building multi-agent architectures. This is an image that I got from the LangChain, LangGraph documentation. What I just show you is a supervisor, let's say, or better, the supervisor approach that Bedrock agents have built. But there are different patterns, and in essence, you can always think about these agents, tools. What is an agent? What is a tool? It's about making sure that you have the possibility to solve the problem that you want to solve with the right set of tools. And this stuff needs to communicate and needs to interface itself. And this is where the model context protocol comes into play. So when it's about making agents or tool communicating effectively, either you write all these very tedious open API specifications, and especially you are mixing the client and the server, because you are typically building an agent which is at the same time your client, but also your server. There is no separation between the client, which could be an agent that contains the orchestration, and all the tools that could be seamlessly used by different agents. This is where model context protocol comes into play. This is just one proposal. It's actually made by Anthropic. It's an open standard. You can think about it as an open API sort of thing. It means that delivers specifications, and I will show you. It's thousands of lines of JSON SDKs to build servers and to allow communications. What kind of communication? For the moment, the architecture that has been released and the code that has been released is you have your client that through the MC protocol can talk to servers, and the servers can talk to data sources or services like APIs. At the moment, everything lives in the same computer, but in the future, you can easily imagine this separation thanks to this MCP protocol or similar others. It means that finally you will have the client, which could be your chat application or any other application, residing in one location, in one server. Then you will have the definition of these tools in another location, so that many clients will be able to connect to the same server definitions, and the servers will connect to different tools. Guys, if you understood what I'm saying, you deserve not one, but many, many free dinners. So if you have questions, please already ask them. I will try to make a wow effect with a demo that showcases how MCP works in practice. Do you have questions? First of all, did you understand anything I was trying to tell you? I will try. Because unfortunately, there are a lot of levels of abstraction. This is what? Wow, here I have the page that is full. I think I should be good. So this is the model context protocol. This is the specification of the protocol. So this is all the JSON that people thought about writing. There are a lot of server definitions that have been built for you. What does it mean? It means that, as I will show you, you want to use a third-party tool, an agent that has been already built, you can very easily integrate it in your application. And there is a library with 1,350 so-called MCP servers. what the hell is an MCP server. I'm getting there. So I used this very friendly Japanese or Chinese Amazon sample, AWS sample, to deploy a little application that is nothing but a little chatbot that provided connection error. But now it works. So this should be familiar to at least some of you. It's a Streamlit application, which typically works as a chatbot, okay? And now the idea is I can select different models. I'm using Amazon Nova. I have some tools, some parameters. And then here are these MCP servers. I have chain of thought, I have local file system, and I have a DB SQLite. What does this mean? In particular, the database SQLite. It means that I have, in the future, because at the moment everything is on the same machine, I will have my database that will be running somewhere as a service. And then I have something in the middle, which is this MCP server that knows everything about the server. And I can build an application by writing 3 lines of code. Connect to this server through, to this database through this server. That's it. And what it can do without me specifying anything about this server will know how to query, how to write, how to update, how to delete. And for instance, I could ask, how many tables are in the DB? And there's going to be some thinking. There is an agent that is undergoing, which has a set of tools, and it will think that there is actually in the database definition through this MCP server, a database SQLite list tables tool, and will call this tool, and we'll see that there is one table with the name employee. And then we'll elaborate an answer, which is there is an employee. Again, maybe it's not easy to identify, but I have a wow effect. It's coming. How to add tools in this application is extremely simple. Let's talk about Tavilai. Deep research now is big, no? Everybody talks about deep research. Is basically a RAG approach where you go into the internet, you retrieve as many results as possible. So you have grounded, results from possibly good sources, and then you provide an answer. These guys have an API, and I am subscribed to this API. And somebody built, where is that? I don't see it. Somebody here built a Tavilai MPC server. What does it mean? It means that if I want to add this tool to my application, I can do it live by just copy pasting these lines. So this is Tavilai. I have my API key. I will change it and I will delete it so you can take screenshots if you want. So here under the hood, what is going to happen is there's going to be a node package that contains all the definition, all the specifications on how a Tavilai API works. And I can integrate it through these lines of code. And as soon as I add it, this now is a new tool in my belt. And I can say, make a statement about the latest NVIDIA stock results. And this new tool that I just added on the fly without any specification, guys. There is no line of code that I had to write. What did it do? It realized that it has a new MCP server definition, which corresponds to Tabulae search. And this tool is able to search the internet, which is the right tool to answer my question. So it will actually call the tool. It will search for the latest NVIDIA results on the internet. These are Business Insider, Investopedia. These are documents coming out of the internet, similarly to RAG. And then will tell me that there was a drop, which is crazy because I've been following NVIDIA. I mean, they beat the expectations and now the actions are like 10, 15% less. If you understand that, good for you. Another thing that I would like to highlight, which is very much more creative, is there are MCP servers of APIs around the world, like this museum in the Netherlands, okay? And I was playing. There is another MCP server definition. Should be this one, yes. That I can simply add through my MCP server definition. This is a bit more delicate because okay, museum. I have to open my Google. Sorry, guys. 1 second. Gmail. I have the API key stored there. I received it today. Please. Good is coming. Let's share again. I share the screen. No? Yeah, leave the page. So this is my API key from this museum. And again, I have no idea about what the definition of the API and anything, but somebody created this wrapper, no? This MCP server. And now I can ask questions like, once I refresh, search for an image containing boats, whatever. And this API, among many things, contains the definition of search artwork. So somebody in the museum took every picture and wrote metadata about it with a description and whatnot. I think it's enough. I wanted one. It gave me 20 millions. So yeah, I receive from the museum images that contain both with the author and metadata. Just because I added 3 lines of code in the JSON and the application didn't know anything about it. So what I want to say is this. At the end of this presentation, agents are very powerful, are extremely complex to build. And what is the future, if you want, of tools/agent is standardization of protocols so that at some point, maybe somebody comes with up with a very smart agent definition, wants to monetize it, and can start sell it or buy it. So that the application ecosystem with the basically agents is gonna be the next SaaS. Somebody said, no, SaaS is dead. The world and the future is agentic. This is more or less everything I had to say. Congratulations if you were able to follow till now. 8 o'clock. Food must be coming. I don't know if there are no questions. Come on.
I think it's already there. So
I am done. Thank you.
Awesome. So let's go with the questions. There are any. Remember, every single question puts you further away from food.
Hi, thank you very much for the presentation. I have a question about this application that you showcased. Could you instruct the agent to download all the images from the Rijksmuseum containing a boat and then storing in the SQLite database? Is that possible? Or?
Yes. I don't think, I mean, I wanted to do something simpler, which was at least display them on the chat, but for that, you need to elaborate a little bit more the application. For sure, you know what? Let's do it. Now you triggered me. Sorry, hey guys, food, I know I need to restart 1 second because networking is not good here. Let's see where we come from. I don't know if I can download. The problem is possibly going to be the download part. But I have the museum, for instance, and database. Okay, so at least the metadata. Let's put it like this, the metadata. Because I don't know if I can download the image.
I mean, I would be more interested in having more automation with something like this. So far, this looks more like, for me, at least as an ignorant person, it looks quite similar to using a chatbot. And my understanding was that with agents, you can automate more. So, so
this is a chatbot.
That would be quite interesting.
This is a chatbot.
All right, okay. So
but the idea is that under the hood, you are starting to use very sophisticated tools that abstract a lot of work for you. Nevertheless, let me try. Okay, search for one image containing a boat, retrieve the metadata, create a new table in the DB, store the metadata in the newly created table. And I am decently confident that something will come out of it. It's thinking, and you already know, get artwork details, create table, write query. So it's doing something. Let's see.
Ask it if you can download. Ask it if it has capabilities.
I mean, the download part, I don't know, because it's not about the download. But there is no tool. Okay, let's try. I will try. If you don't want to go to it, I can enjoy it. So now this is still running, but the table was created successfully. You see, first it retrieved a lot of images with the description. So it's now doing that. And look at this. The artwork metadata, it had object number, title, description, dimension, even production places and physical medium. I mean, this represents pretty well, I think, the output JSON that was from the API. So, I mean, it's crazy, no? It takes an API, doesn't know any, I didn't write any line of code. I just added these tools. And now goes to the API, retrieves the result, analyzes the API, takes the indices, creates the table, and then stores everything in there. So it's working, I assume. I don't know if he has written in it. Thinking. Maybe there was a timeout. It is possible that there was a timeout, but you got the gist. Because I think it's capped at 30 seconds, I think that I would not be surprised.
But so in theory, it would create the table now on your local SQLite?
It did. Yeah.
Oh, that's pretty cool.
I don't think it populated it, but for sure it created it. You see, employee artwork metadata.
That's nice, cool.
So that's it. I mean, oh no, it's there. Yeah, it filled it too. So that's it. You can, of course, automate this. It's just the display purpose that please.
Is MCP like a marketplace for anyone?
It's a protocol.
Because you showed a list of like 1,200 servers.
It is becoming a marketplace in the sense that you can, for virtually any API or virtually any agent, you can create an MCP server specification. The API or agent need to run somewhere, and then you can connect to it by this, let's say, wrapper with these 3 lines in the JSON. So essentially, it's the evolution of the APIs. It's becoming a marketplace. It's the marketplace of agents at some point.
Are these actual servers, instances, or are these definitions of a server?
Definitions. They are also running through a node in whatever. They are definitions in essence, but they are also running. But they are definitions.
Some people are running.
Me in particular. No, because all you create is the wrapper, and then the wrapper needs to run in your local, but it's a very lightweight thing.
So you mean that, can you go back to the picture first?
To what?
To previous screen. Yes. So there is an SQLite. So you mean that I get definition of SQLite, I start my own SQLite server and connect this definition to my server to get the MCP say agent, and then I can use this on the bot, chatbot, or it's some public SQLite server which is.
No. In this case, needs to be. I think most of the time is running locally. These SQL communication or these SQL servers I have seen mostly are the local ones. So it's like running on your. But the evolution is going to be the server running somewhere, and then you connect through.
And this definition contains all the operation which I can do.
Exactly.
Okay.
Because SQLite or MySQL or PostgreSQL work all the same way. It's a standard.
Yeah.
So you create the wrapper, and then the agent will know everything about it without you writing any line of code.
Really cool.
Your hosted is inside your agent.
Exactly. Hosted somewhere else and included as a tool in your agent.
The way that you built your app, the one that you were showcasing, you added the agent that fetches the image. So first you have some other model that chooses the tool given the prompt, right?
It's always, if you remember the very initial agent description, and in this case, allow me to drive you partially wrong in the sense that it's not a super mega hyper proper agent. It's a language model that is enhanced by tools. The workflow is always the same. It's not a Bedrock agent, but you have a request, you have a foundation model that takes the request, checks all the tools that are available, and then elaborates a plan, boom, 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 executes, returns the answer. I am making a little bit of a melting pot because there are too many things if you go at the fine print. But this is how it works.
Awesome. Any last question?
Sorry, can I ask one last Amazon? Can I ask an Amazon specific question? So is the plan, for example, Postgres, I deploy a Postgres instance. Are you going to have a little checkbox that says you can have an MCP endpoint attached to it automatically?
That is indeed what I try to represent here, right? You are going to have an application, and MCP is just one protocol, but it's very, very common, right? And it's taking off. So you are going to have the client, like the chatbot, or an agent, or whatever you want, that is built somewhere. The servers with the definitions of your tools, and then connections to remote. In this case, I already connected to a Tavilai API, which is hosted somewhere. So the agent already and only make the connection between what is called here the MCP server and the server itself. So in the future, yes, PostgreSQL is going to be somewhere. You spin up the server that contains all the definition of a PostgreSQL server, and then your agent will be able to use it on the fly because the definitions are written here and your client just uses these MCP servers. It's one-on-one, yes. So the errors here are double, so it's always bidirectional, but there is a statement in the sense that The remote MCP server, it's one, I think, to one client, if I remember correctly.
Query one API and then data back into another.
Maybe there are too many levels here. So you can always spin up different servers and connect your chatbot to different servers. If you looked at the chatbot, I had different boxes. I tickled only one, but you could have actually ticked all them, and it handles seamlessly, chooses the right tool. The way back is one-to-one, as far as I remember. So you need to have your server that you spin up for your application or something like this. Or local, because they are so light. But these are very great questions, and I am not even sure I can answer all of them. I'm still trying to understand myself.
Awesome. Then we'll take questions from Krakow if there are any.
No, they are hungry.
I think we are all good, but we want to take the opportunity to thank all of the speakers for the great presentations, and cheers from Krakow, everyone. And yeah, all right, that's it from Krakow. Enjoy networking.
Thank you so much. So yeah, I think the snacks are already waiting. Get yourself something, and thank you everyone for joining. And as once again said, if you want to talk on our meetup, just please reach out, contact@zurichai.club, and we can figure out something. So once again, thank you, and thank you to all of the speakers for their time.